All right. All right, welcome to week 6. This is going to be an unusual week because today I will pretty much just be talking about the code for this chapter, because I'm going to talk about a lot of things that aren't necessarily covered in this chapter. Because this is a good time for me to talk about how things get done and how to finesse code and stuff like that. So we will not spend a lot of time on final projects today or talking about database build. I will answer questions as they come up, however. We'll be going over a lot of things that I really haven't talked about to this point. Before I begin, are there any questions on last week's work, this week's work? I am fully graded. I'm caught up on my grades. Everything from week 5 is graded. So all your paper has been graded. Everyone's ideas for I don't know why I made it seem like I had to approve your idea for a final project. I didn't have. Jason, you've got some medals back there, man. Are those like running medals?
Those are my wife's medals for doing like Foam Fest and
cool.
stuff like that. They're running, yeah.
Fun. Oh, sorry. I got distracted. What was I saying? Oh, I don't have to approve your final exam, your final project. You can do what you want. Thank you for coming to me and asking me my advice and stuff like that. But everyone's ideas are great. There's a couple out there that I'm really looking forward to seeing how they flesh out. The other thing I found out today, well, Monday, if you are in your workbench and you go here under help and check for updates, you'll find that there's an update that'll bring you up to 8.0.31. And guess what? In 8.0.31, the words intersect and accept actually work in MySQL. So that's pretty exciting on the engine front. So if you guys want to play with it, upgrade it, and those commands are there for you. I haven't gotten around to it right now because we're past that point for me, and I'll worry about it next semester. So any questions on anything week 5 or 6 related?
I have a question. I don't know if I missed any some of the paper, or I don't know where were we supposed to let you know if we would like to do the project or the exam?
If you want to do the exam, you don't have to tell me. If you want to do the project, whenever you want to start doing it in your weekly papers, you tell me what you're doing for your project that week. For example, if you were going to do your project on, you want to make a database to track wildlife in a zoo, right? You want to make a zoo. So you say, I'm going to make a zoo wildlife database. And then like next week, you can say, okay, here are the tables that they've come up with. If you decide to do the final project, your papers at that point become like a journal entry to me to tell me where you are and how you're doing with your project.
And we wouldn't have to do the normal assignment for the paper then?
Nope.
Okay.
Nope. And then your final project is due in week 13.
Got it.
Yeah. And if you're not sure what it was, go back to the week 3 video, and it'll explain what it is. And I gotta check these chat windows here. Hey, Mariana, who has any questions? Oh yes, thank you for bringing that up. I did not get to it in time. I apologize. The questions about VI editor don't exist in any of the reading material. They're not there. Just to give you some background stuff. So I found out last week that they're letting me actually make changes to the course to fix things. So this will be the last time we actually see those questions there. If you see any questions, I'm going to try to get to it tomorrow. If you have not taken the quiz yet, please don't take it until tomorrow night. If you have taken the quiz, I will go in there and delete the VI editor questions because they have nothing to do with anything that's ever been taught in this class since it started 7 years ago. So yeah, thanks for bringing that, Mariana. Someone else had brought that up in an email, and yeah, there's a lot of them. If you got them, I'm just going to give you credit for the questions. So if you got, yep, Gabriel, you too. Yeah, I got to go through them. There's like out of the, I think there's a pool of like 50 questions. There's actually like 20 that deal with VI editor. And you must have just gotten lucky and got more of them. So yeah, I'll go through all that. I'll take care of that. Thank you for letting me remind me this week 6. And hopefully, like I said, if you haven't taken the quiz yet, please don't take it until tomorrow night. So I get in there, delete the questions. If you've taken it already, I'll go through your quizzes and give you credit for the VI editor questions. Okay. Any other questions about this week's lesson or last week's lesson? All right. So what I want to talk about is the lesson of week 6 is about putting data into tables. So what I'm going to do tonight is I'm going to go over how to create a table, the different steps in creating the table, and the code behind it, and why we do it. We're going to go over primary keys, what they do, and how they work. We're going to go over insert statements in various ways, shapes, and forms, delete statements in various ways, shapes, and forms. We're going to talk about how to do transactions, which if you take away anything from this week into a professional career, take what we talk about transactions, because believe me, it will save your skin at some point in time. And we'll talk about delete statements and how to write delete statements. We'll talk about the truncate statement. And along the way, we're going to do a couple different commands that you wouldn't normally see just for fun. Okay. So up here, let me draw my table first here. Okay. So I'm going to create a table called persons. I'm actually going to call it person because it's not supposed to be singular. And I've also got to, before I forget, I've got to say use Sakilla. Okay. Use my Sakilla database. Use skill, please. There we go. I'm going to drop my persons table. Okay. So again, because transaction SQL is English, I do create table person, and this tells I'm going to create a table called person. Okay. Then I've got to identify each column, the data type of that column, whether it can be null, and any other commands that go with it. So every table must have an ID column. So if person ID, I have it as an integer, and there's a video I've got to share with you guys that goes into great detail about data types and their sizes and what they do and why you have them. Did I talk about that last week? Why we choose specific data type sizes over other data type sizes? So just real quick. So you've got tiny int, you've got small int, you've got int, and you've got big int. And you say to yourself, why do I have 4 different data types for integers? Okay. 8-bit, 16-bit, 32-bit.
Does it differentiate between how much memory they take up?
How much disk space they take up. How much disk space they take up. So you're dead spot on there, right? So tiny int, it only takes up 8-bit of disk space and memory space. Okay. Small int takes 16-bit, if int takes 32-bit, and big int takes 64-bit, which means if memory serves, and don't quote me on this, I know the sizes are right, but I don't know if the numbers are right. So tiny int is like -256 to +256. And that's the only numbers that you can use. Small int is like -64,000 to +64,000, somewhere there. Int is like -2 million to +2 million, and big int is just ridiculously huge numbers. Okay. So why would I use tiny int versus small int? Well, first of all, if I knew, let's say I was going to make a table for colors, right? And I know that there aren't more than 256 colors in the world, right? I would make my ID tiny int because it doesn't need to be bigger than int, Because if you look at it, so tiny int takes up 8 bits of space, right? So you all know that there's it's like 1024. Oh, sorry, yeah, 1024. It's not bytes, this is bytes, it's not bits, bytes. It's bits. So I'm not getting into the math. I'm not gonna attempt math tonight. So 8 bits, 60 minutes. So if I use tiny ints and I use 20 columns, that's 160 bits, right? But if I make my column big int, and I do 20, that's 1200, something like that, something like 1200 bits. So if I, depending on this is how much space it's going to take up on my hard drive, right? So I think I told you when I worked for a company called Property Insight, we had a table and the ID column was int. And it stopped at 2 million-ish, right? And when they had designed the database a couple of years before, they chose int because they never thought they'd go over 2 million rows in that database. 5 years later, they're at 1.6 million rows, and it was growing quickly, and they had to change to big int, or they're going to run out of rows. Because if you use int and you try to do, if it's 2 million and you try to do 2,000,001, you will get an error, out of range exception. You can't put that here, right? So what they ended up doing is they had to take this table of 1.8 million rows and change the ID column to big int, which you wouldn't think is a big deal, but you're literally doubling the size of that column bitwise. So you had, so that column, I don't remember how to translate out, but that one column, when I did the math, was something along the lines of 256 megabytes, something like that, right? So all of a sudden, no, it was more than that. It was 256 gigabytes. So when we changed to big int, that table went from 256 gigabytes to 500 gigabytes of space taken up because of the change. Okay. So when we choose our data types, we got to make sure not only do we choose the right thing to get the right amount of value in it, but A, is it big enough for the intended use of that table for as long as this company is going to exist? And B, is there enough space on the hard drive for this table as it gets full? And these data types force that to happen. Okay. I have a video somewhere on my YouTube channel, like and subscribe. That I'm just joking about the liking and subscribing. I have no aspirations of being a YouTube personality. It's just way too much work. I couldn't even imagine doing that much stuff on a daily basis. These people are just amazing. Okay. So person ID, int, not null, which means it has to have a value. It can't be empty. Then I have this thing called auto increment. And auto increment means that it will add 1 to the last number that was used. So you don't have to put a value in. We'll talk about this on the insert table. I'll show you that in a second. Okay. Last name varchar 255. So varchar, there's char and there's varchar. Okay. Anyone want to guess the difference?
So one is an amount of character fixed, the other one could be variable, and you can set the amount of characters or the length of the string that you want in that. Feel like for a first name, you should do a var chart because not everybody has the same amount of letter in their names, for example.
So you're very close. You're very close. So the difference is if I do char 255, when that column is saved on the hard drive, no matter how many characters I put in, it will save the space for 255 characters. Okay. If I do varchar 255, it will save up to 255 characters, but only use the space for what's there. Think of,
Can I ask, what would be the point of not using varchar for everything then?
There is none. You would use varchar for everything.
Okay,
Some people, I mean, char is a legacy. Varchar has only been around since 2002. So char was there originally. So you'd have to be careful. Like, okay, if I'm going to do phone number, it's char 10 or something like that. If I'm going to do age, well, whatever it is, you know, you do that way. But with varchar, you do this now. Some people still do char 1 for like gender or something like that. If there's only one character in there guaranteed. But most places you're going to see do varchar. Okay. So let's keep going. So we got last name varchar 255, not null. First name varchar 255. If I don't put anything there, it allows nulls. Okay. Age int. Is that my best choice? Does anyone here plan to live to 2 million years old?
maybe.
You know what? I keep telling people my goal is immortality. And
Not even if I could.
you know what, I'd give it a shot. But and if I'm ever proven wrong, it's not gonna make a difference at the time. So I mean, eternal immortality is one thing, but I don't want to miss any movies that come out, you know. I'd be really sad if I missed Black Adam this weekend. Age, tiny int, because none is only 2 million. 256 is a reasonably good age. Email varchar 255. Now, primary key. I could have put primary key up here. But I put it down here because I want to remember to talk about it. The primary key of a table is the column by which the table is organized by default. Okay, the primary key is the column by which the table is organized by default. Do you have to have a primary key? No. Should you have a primary key? Yes. So this is a preliminary index for your table. Okay. A primary key can be up to 3 columns. So you can have 3 columns that make up the primary key. A primary key cannot be null, and it can never be repeated. So in this table, person ID can never be repeated or it will error because it's the primary key. If I have 3 columns in my primary key, the combination of the 3 can never be repeated. So column 1 could have 8 in there 16 times. As long as the other 2 don't have repeated the same way, it's fine. So I'll go ahead and create this table. And the table has been created. And I'm going to select from that table. Okay. And there's no results. So I have an insert statement here. And I have insert value Williams, Venus, 27. Is this going to succeed or is this going to fail?
It's going to fail because you still have persons.
Oh, thank you. I'm going to fix all that. Makes me not want me. You know, I should just do this then. I should just do this because I'm gonna be too lazy to change all my code. I'll have to do that later. Okay, but good catch. It's totally gonna fail for that reason. So I'll go here and make this persons again. Create my table. Okay. Select table for persons. Okay. Run that. Good stuff. Go here. I'm gonna try to run this now. I'm gonna try to run this. It failed. Why did it fail?
Because you didn't specify the other columns for the other values.
Okay. Which columns did I have to specify?
Just the ones
The
that are
first
not
name,
right.
Last
last
name.
name, and age.
Doesn't
Okay.
know what.
So
You need to specify the last name because cannot be known.
last name's there. I got the last name there.
Okay.
Got the first name there. Okay. I've got age there.
But you're not telling
But
them.
then,
put the
yeah,
values.
but then you need to say what is, right? Or no?
I'm gonna try to run this one.
No.
Okay. I still have no values in here. Where's that one? That one should have worked. So this one should have worked. Okay. So neither of these work because I have all these other columns here, right? Now, normally it wouldn't matter because the only ones I have to put in are these two. Why are those the only two I have to put in?
Because those are not null,
Right, those are not null.
have a required value.
But the problem is with these, I have three values that are going in, and I've got 1, 2, 3, 4, 5, 5 columns. So it doesn't know which ones those are supposed to go into. So over here, and now I always recommend writing insert statements this way. So here you get insert into persons, and then these are the three columns I'm inserting into. So it knows. So if I run this, this runs fine. Did I just drop? Oh, shoot. I just ran everything at once. That's fine. Okay. Go back to here. Okay. Okay. So here I'm going to go and insert into persons, last name, first name, and age. And that worked fine. And I'm going to select from person, persons. And now notice I didn't put the ID in for this. I just put last name, first name, and age. I don't have to put the ID in because it's auto increment. It was 0, it went to 1, it went to 2, went to 3, it'll do whatever it wants to do. Okay. Now, insert into person, last name, first name, age, value Williams, Tennessee, 27. Insert into persons, age, last name, first name, values 102, Williams, Willie. That works fine. Because I told it what the column order was going to be in and give the values in the order that we put in. Okay. So when you're doing your insert statements, you very much want to do this so you know where the columns are going to be. Okay. And like I showed you, if you create the table and go over here to this and click on that, it will give you the insert, it'll write the insert statement for you.
Can you specify parameters for the auto increment, where to start, what format?
So what you would do in MySQL is you'd go here and put the first value in on the first one. and then seed it from there. In Oracle and in Microsoft SQL Server, it's called identity, and you give it the starting number and the increment that it goes by. But MySQL is kind of simple, so it's just put that. So if I go here and I insert this, it lets me do it without a problem. And when I select from persons here, oops, I select from persons here, it jumps it to 16. And if I insert these two things again, it picks it. Oh, doesn't just not run. No value. Oh, sorry. Oh, I ran the wrong two ones. I wasn't the two. I ran the ones that wasn't gonna work. So this here. Okay, there we are. And if I go here, it goes 16, 17. If I go here and try to run this again, I get an error. Duplicate entry 16 for key primary persons. Okay, because that's primary key, so it can't be duplicated. If I do this, so go here and delete where person ID is 17. I get one row reflected, so I go here and select star from persons. 16 is gone. If I go here and insert this again, that's 16 is that one. If I insert this again here, and I select star from persons, notice that it's 18. So the auto increment has nothing to do with the number that's in person ID. It remembers in the metadata what the last number used was. So we'll never reuse 17. You can, if you want, insert it manually. But if you have auto increment and you delete a row, the next number will be the next one that it knows that it will use. So if you delete 17, it will go directly to 18. It will never reuse 17. Everyone good? Any questions? Everyone following along? All right. Here you'll notice I have this. And all this is just a fancy way to generate a number. Random gives, so we'll look this one on, just this is kind of fun. Select. And it just gives me this random number. It's a number between 0 and 1. So I have this whole thing here. I do random 25. And what that is, it gives me a number that goes at 25. It starts, it's between still being 0 and 1, taking 25 places. And then I multiply that by 50. And that gives me this. And then I added 10 to it because it can be any number of things. Right. And then I do plus 10. Anyway, it's just a way to generate random numbers. That's nowhere on a test anywhere. I just like using it because I like doing random ages into here. If I'm going to do a number of inserts at one time, I can do it this way. Insert into persons, last name, first name, age, values, Williams, Tennessee, random, comma, Williams, Andy, Williams, Jenny, Williams, Willie. So I have to write the one insert statement, and then I can do under values as many as I want to. And that just inserts the 4 rows. And there's 19 through 22. I can also use an insert statement and select from another table. So here I've got select lower last name, lower first name, and a random number from actor. So what lower does, just so you know, is it forces every letter into a lowercase. And you would imagine there's a command that calls upper that does the exact opposite. So I can take this select statement here and just populate the table with this. So I can go here and do this. And I've inserted 200 rows. I go here. And in my person table, I now have a whole mess of rows. Okay. Okay. So any questions on insert? Pretty straightforward, right? Bunch of way to do it, lots of fun things. This select query makes it a lot really easy to do it. And again, once again, when you're writing your queries for your final projects, if you create the schema and go over here and right click it and say, send a SQL letter under insert, it will write the insert state for you. You just need to fill in blanks. Doesn't get much easier than that. Okay. Update. Inserting is for putting data into a table. Updating is for correcting it or modifying it or changing it. Here I'm going to say update person, set first name equal to first name into upper first name for age between 12 and 25. So I'm just going to, anywhere there's age between 12 and 25, their first name is now going to be uppercase. See there, no, Debbie didn't make it. Kim's there, Cuba didn't make it, Meryl didn't, Angeline did. So update is update the table. Here's what I want you to change. And here's where I want you to change it. Here's another one. So here's another interesting one. So now I can do an inner join on an update statement. I'm going to update the persons table, inner joining the customers table, where person's last name equals customer's last name. I'm setting the age to 999. Now notice I didn't alias anything because in update statements, aliases don't work. You've got to write them out. So I'm doing here is like I'm updating the person's table. I'm joining it to the customer's table. And wherever the person's last name equals the customer's last name, I'm changing the age to 999. Oh, okay. That's my fault. I did that tiny, so let's just change it to 99.
Brother Stevic,
Yeah.
does the capitalize, does that work as well in SQL?
What do you mean? Upper?
So you used upper and lower, but in a Python, you can use capitalize. That must work here too then, or?
The word
Means
capitalized.
make
It's got
make
it's
the
got to be.
first letter capital.
Oh, that doesn't work here. No.
No? Oh.
Yeah, no. That's not a real command in it's not a function in SQL. if you wanted to do that, you have to do like, you know. Update, see, you'd have to do, update. Maybe this here. This. Okay, so you'd have to do upper. I'm gonna do this. Upper first name substring. Substring. One. First name. Plus. Lower. 2 comma. So we do this, let me run this one first here. So I'm gonna update persons, interjoin that. That'll work because I'm not out of range. And I'm gonna do here where age equals 99. And I've got all these people who are 99 now. And then I could do this where age equals 99. I think this will work. And if I run this, no, it didn't work. I'll let's see, can get some string. Oh, here it is. That's what I did wrong. Substring. First name. There we are. Yeah, do one more. There, okay. Yep. And do this. Here. To. That work? Yep, that worked. So I go here. Oh. Well, I goofed that up, didn't I? That means there was no value there. So first name is what do I do here? I'm gonna go down this rabbit hole for a second. Hang on. Now I'm curious how to do this because capitalize doesn't work in. Actually, as far as I know, capitalize doesn't work in any T-SQL statement. It's not a T-SQL command. Okay, so nothing's coming up there. So why is that happening? Let's do this. Okay. One, four. What am I doing wrong here? Hang on, let me abandon this for a second here and just dump down to here. Okay, so let's see here. Oh, that's what it is. Okay. Something's not right. That's what the problem is. I've got nothing in my first name column. I accidentally updated. So I accidentally updated my first name column to be zeros across the board. So that's why nothing's coming up.
Oh, okay.
I
I
broke-
found an example of something on a website
Oh, for
for exactly what you're working on there.
oh, yeah, it's this is actually a good example of update statements breaking a lot of stuff if you screw them up, which is what I did. I broke everything, so I'm going to go ahead and just recreate everything. And go here, and just those aren't going to work. So let's do this, do so do this. Do these. Yep. Let's do this one. Do that. And most importantly, let's do this one. Okay. So before I mess anything else up again, I want to go down to here. So I want to talk about these commands right here before I mess anything else. So whenever I run code like this, it's considered a transaction. Okay. Anytime I highlight the code, run it, it's considered one transaction. If I explicitly call it a transaction in my code, I can run a command and then I've got two choices. I can either roll it back or I can commit it. Okay. So I ran this code up here before. I changed a person's customer, changed the last day name, with last name's match, I changed it to 99. And I did that just knowing I was just going to happen and whatnot. So here, if I run this with the explicit transaction, it's going to run. It's going to tell me if it works, how many rows were changed, how much was affected, but then it's going to roll it back to the way it was. Okay. If I use these commands, then I can test my updates before I actually do them to make sure nothing breaks. And if you noticed, if you rewind 5 minutes, I don't know where I did it, but at some point in time, I changed all of the first names in my table to the number 0 and broke everything. This is why transaction was made. If I go here and get rid of rollback, and I do with commit, it makes the change and doesn't roll it back, and now it's permanent. Oh yeah, that's what I was trying to get to. Yeah, but the problem was my code was right. The fact that I changed my column to all zeros is what was breaking it. That's why it was actually returning correctly. Just my data was wrong in my table, which is a valuable lesson. Sometimes the query is given the right example, you usually have the wrong data. So these are transactions are a great and handy little thing to use, because sometimes if we're not paying attention, we will break our databases because we'll make an update that breaks everything. So back over to here. I want to update I don't have an email in my email table right now, right? So I want to go ahead and put an email in there. So I got a little string here. I'm concat. So concat, and this is on your the weekly stuff. Concat is taking multiple strings and putting them together into one thing. So here I'm concatenating the first 4 letters of the last name the first name rather, the first 4 letters, the last name, and then adding gmail.com. And this is a global change. I'll do that. And now my email field is now populated. There's a command called replace. If I know that there's something very specific I need to replace in my string, I can do that. I know I misspelled Gmail. I can go in here and say set email to replace. In the column email, where you find this, put that. So if I run this, it's now been corrected. Everyone good so far? Anyone lose anyone? Everyone following along? I can remember to check the chat here because people chat and I miss it. Okay, we're doing good. All right, almost done. Like I said, there's a lot of coding tonight. Did that, roll back, commit. Okay, delete. I can delete bulk like this. Delete from persons where last name like W. I'm gonna use my transaction to make sure I'm doing this right. Okay. It'll delete 25 rows. That's what I expect. So I'm gonna go ahead and commit that. Now deleted 25 rows. I can also delete using a join. Delete persons from persons, inner join customer, where person last name equals customer last name. So anywhere that the same last name exists in person, exists in customer, I'm going to do it. I'm going to put my transactions around it. Get my rollback back. I'm going to run it. And if I ran this for real, I would delete 32 rows. If I put a select statement in here, it'll show that before the rollback. So it'll tell me exactly what changed. Okay. So that I know that's going to work. I'll get rid of my rollback and I'll commit it. And I've deleted 32 rows. So, okay. The last command I want to discuss. So everyone good with this? Everyone kind of seen the rhythm, how this flows, how it works. You can do inner joins, all this other crazy stuff. It's all there for you. The last command I want to talk about here in the last 10 minutes is a fast one, and then I'll open it to questions, and we'll call it a night. Is this truncate table? So I may have explained this before, but when I run this command to delete this stuff, okay, this deletes row by row. So I deleted 32 rows, 1 row at a time. Okay. When I do the truncate table, so let me yeah. So I do the truncate table. It'll just do everything. So let me do this here. Delete. Okay, so I do where go back to here. This one here. My customer last name is like A. I'm gonna roll back. It would delete 4 rows, right? So if I just delete that, it's delete 4 rows. I'm gonna do that. So it tells me 4 rows are deleted. If I do truncate table, it says 0 rows affected, but there's nothing there anymore. So truncate table just flushes it, just empties it out completely, and doesn't keep track of how many rows it did. It just gets rid of everything. So it's a fast way to get rid of what's in a table. Okay. And that is the full run of the DML commands. Insert, update, and delete, and truncate. Okay. Are there any questions on this material?
So the main difference between the delete and the truncate is the delete goes through line by line and the
Yeah.
truncate just drops it all.
So yeah, so let me dig a little deeper into that. So did I talk to you about transaction logs? So whenever you issue a command in a database, just to remind you, the command gets issued, it writes to the log first. And then that command that's in the log goes against your database. Okay, so when you run a delete command, it logs each row that's deleted in the log and then deletes it in the database. This way, if you ever need to roll it back, that's why rollback works, because it goes back and says, hey, all these things were deleted before I can put them back, right? Truncate doesn't write to the log. Truncate just goes empty it. We don't care. And all that's in the log. So if you do a delete statement in your log, it'll say delete row 5, delete row 6, delete row 7, delete row 8. If you do truncate, it just says truncate and has no idea what it did. It just gets rid of everything. So that's why that works. So yeah, so delete is R bar and truncate just all or nothing.
So you can't roll back a truncate.
You cannot roll back a truncate. If theoretically, if I did this in a production database and screwed something up, I could go back in the transaction log if I knew how to do that and bring everything back. If I ran this in a production database, I'm just gonna start filling out my resume. All right. Any other questions? All right, then.
I do have a question.
Hit me.
And probably it's a little bit about what you were showing at the beginning. So in the real world, when you're creating a database or us, when we will start working on our project and we want to create tables and put information on it, like, is there like an automated way to do it, or you just have to type everything one by one, row by row and column by column of what you want in your tables?
So last week, I made this in the workbench. Oh, that's all there. 2 weeks ago, I made this. Nope, that one's not gonna work. Oh man, this will be fine. I had a whole database here last week and it's not there anymore. I messed up. I didn't save it in time. So if I go here and create all my stuff in here, right? I can go to here. Wait, where is it? Database. I can go to forward engineer and I can say, give all this information here, hit next, generate, he's going to generate all the creation, not going to skip anything. Sure. Okay. I'll click next and then click next and it will create my statement for me. So if you're going to do the final project, I strongly recommend you design your database in here and then go to here and go to forward engineer and let it write the code for you. Okay.
Yeah,
And-
I've done that. My question will be then, once I have my code with all my inserts, because I've done it before, should I just go like one by one and put the values? Like, is that the way to do it?
Not one by one. You can use the command here for insert where you do the multiple inserts in the same time. But yeah, you have to do that. So so the thing about inserting data, and this is something I'm going to answer in a couple weeks when I start talking about use case scenarios. Before you start adding data into your table for your final project, write your use case scenarios. Because your use case scenarios need to return data. So when you write your use case scenarios, you'll know what data needs to be in the table, so you can put the data that needs to be there. So I'll get results back when I run the use case.
The use case scenarios will be like the result of the queries that we will write once we have all of our data ready, right?
Right, like, so
Okay.
let's say, like last semester, someone did a database on their food storage. Right, to keep track of their food storage and how this, so they had use case scenarios like what items in my food storage are over a year old, and they'd write that query. How much freeze-dried corn do I have? And they'd write that query, okay? So that's what the use cases are. So when you're writing your use case scenarios, then you say to yourself, okay, I've got a query that says, how much freeze-dried corn do I have? Well, I better have some freeze-dried corn in my database, or it's not gonna be any results, and I'm not gonna see anything. Yeah. Make sense? Cool. All right. If there are no other questions, I'm going to end tonight's meeting, and then I will talk to you guys next week. All right. Have a great week, guys.
You too.